Alright, here we go. Honors Algebra 2. Shout out to Christian, Van, Nick Lee, and Carl from Family Matters. Why, I don't know, but why not? Alright, so let's do this. Today is actually pretty easy if you have grasped the other 2 days, especially since the first 2 days were pretty much the same thing. First thing you got to do, find the following information for the function. This is just a review. So, first thing you got to do, write down the amplitude. Just look at the number, it's 7. Remember, the amplitude's the first number. The frequency, remember, you want to factor this out first. So this is really 4 theta plus pi over 8. Now we can see, you could have seen it before, but the frequency is 4. There are 4 graphs within 2 pi. However, the phase shift, do you see why you needed to factor that out? So now you can see clearly what the phase shift will be if we solve this. So it should be pi over 8 to the left. Now remember, please tell me which direction it goes on the quiz when you see a chart like this. Vertical displacement, 6 down. Period of 1 cycle. If I divide by the frequency, I get the period is equal to pi over 2. So it's pi over 2. Equation of node line. Again, equation means you need to have an equation on that one. Y equals -6 because it went down 6. So if the amplitude's 7 and we're starting at -6, we get all the way up to -6 plus 7 is 1, or -6 minus 7 is -13. And I don't know why I wrote -7. So that is just kind of a review. Today what we're going to be doing is we're kind of basically doing the same thing except for working backwards. So I'm going to start you with a curve and you have to go the different direction. So steps, basically you can box off a sine or cosine curve, figure out your node and amplitude, and then deal with the inequality and put it together. So for this first problem, you have to do it in a sine function and a cosine function. So I'm going to start with the sine function. I will define my sine function. So you basically get to pick what you want. Sine functions start at node lines. So I want to do a full cycle from here to here. So if I box this off, if I want to box 1 cycle, just to help me see what I'm looking at, and you might have to do this too. Make sure if you box off a cycle, it's a nice box. Don't do this and that. Yeah, no, don't do that. Make it fit nicely. Alright, there's my cycle. Now, what does this tell me? I have to find the node line. Well, the problem with this is I did not give you a node. So, but I did give you a top and a bottom of the graph. Well, the node is just the middle line of the top and bottom. So, if I do for the node, if I do 2.56 plus 0.34 divided by 2, finding the midpoint, then I get 1.45. So that's my node line. Now to find the amplitude, I go from 2.56 to 1.45. So the amp is 2.56 minus the 1.45. Because now we know that this is 1.45. So you get a 1.11 for the top or the amplitude, and it's positive. This is going to be a positive amplitude or a positive curve because the way I just defined it at my node line. Notice how it goes up first. Okay. So here's the best part. I defined a curve. Look at where your curve goes from and to, and make your inequality. My inequality goes from -16 degrees to 20 degrees. So now you have to think in reverse of what we used to do. We used to do the last step being the phase shift. So let's unphase shift this thing. So we have to get this side back to 0. How do we get the left side back to 0? We add 16 to everything. Okay, so we have 0, theta, 36. So the period of this graph is 36, but we now need to get our frequency back in there. Oh, and what did I forget to write? Forgot to write theta plus 16 in here. There we go. So The last step is to get your frequency back into the guts of the problem. In order to do that, remember the first step you do is usually divide by the frequency to get this 36. We want to get this number back to 360. How do I get that number back to 360? Because that's how we normally start our inequalities. You multiply by 10. So now my inequality is 10 times theta plus 16 to 360. And now we have the guts of the problem. And now I can just write the equation. My equation for this graph, and please write an equation, y equals my positive amplitude of 1.11, and it's positive because I defined it as going up, sine of 10 times theta plus 16, and then the amplitude or the node line is at 1.45. And there you go. We just came up with the equation that would give us that graph just by working backwards. Cosine is the exact same thing except for basically a phase shift difference. So if I want to box cosine now, you guys could keep yours boxed up there. By the way, you don't have to find the node line or amplitude again, do you? For a cosine and sine curve, and they're both the same amplitude, same node line. So for cosine, let's go here. Cosine starts at a top or a bottom and goes back to the top or bottom. So if I want to box off a cosine curve, this is what it would look like. I'm going to graph that or write an equation with respect to that curve right there. So we already know the node and the amplitude. Excuse me. So let's do the middle part, the guts, to find our frequency and phase shift. I just defined this function going from negative 7 degrees to 29. It's basically the same thing as over there. We have to get it to 0 first, so move the phase shift back by adding to 7. Oh, I should probably just write. So when I add 7 to everything, you still get the same you still get the same 36, which you should, because the curve still has a period of 36 regardless of where you're picking from. And now we multiply by 10. So the guts of this one are 10 times theta plus 7. But notice how the curve equation will be very similar. Oh, and I chose positive cosine because I started at the top, so that's just something I have to note. Alright, so my amplitude is 1.11. I did a cosine curve. It's still 10 theta degrees plus 7, and then plus 145. 1.45, I should say. So again, same thing. The only thing that changes from cosine to sine is where you're starting and ending the graph, so the phase shift is different. Because remember, the phase shift is all dependent on the 0. And that's it. That's all you got to do for these. Alright, so let's do one more side with 2. Again, you can, this will be in radians. You can decide to try this on your own first, or you can watch along. First thing you got to do is find the node here. So I have 3.5 plus a negative 0.5, because that's the top and the bottom, divided by 2. So I get a node of 1.5. And I'll just put that here. So, and then the amplitude should be pretty easy to see. From 1.5 to 3.5 we go up 2. So the amplitude's 2. Alright, so for the first problem I want to do a sine function. So let's start, oh, this is perfect. The sine curve starts right at the 0. So let's define the sine curve from here to here. So if I wanted to box this sine curve out, there it is, minus this piece there. Alright, that's the function I'm using. So I look at the guts, I go from 0 to 2 pi over 9. Alright? So when I write my inequality, I go to 0 from theta 2 pi over 9. Well, there is no phase shift because this side is already 0, so it's starting at 0, which is perfect. So the last thing we have to do is just get this back to 2 pi. How do we do that? we multiply everything by 9. And then we get 0, 9 theta, and 2 pi. So the guts of this problem is just that the frequency is 9, which means that the graph will happen 9 times within 2 pi. Remember, frequency is how much it'll happen within 2 pi. Okay, so now I can write my equation. Y is equal to, I made a positive sine curve. My amplitude is 2 sine 9 theta, and the node line was at positive 1.5. And we're done. Cosine function, same thing, except for there will be a phase shift on this one because we are not going to be at the 0 because the cosine doesn't start at 0. If I want to box out a cosine, and you can choose to do like negative cosine, but always choose ones that have numbers written there. So if I chose negative, I could do this and this, but this one doesn't have a line there, or a number. Same thing with that one. So it's pretty much set up that you would choose positive cosine here. I'm going to box this off just to double check and see my values. There's positive cosine. Alright, so my amplitude and node are the same, so I just have to do the inequality. It's very similar. In fact, the only difference is there's a slight phase shift. This goes to 5 pi over 18. Okay, so to undo the phase shift of moving it pi over 18, I subtract pi over 18 first. So I get 0, theta minus pi over 18, and 5 pi over 18 minus 1 pi over 18 is 4 pi over 18, which is the same thing as 2 pi over 9, which sure enough was the period on the last example over here in the sine function. So now we just have to multiply again everything by 9, just like last time. The frequency will be the same. So I have my inequality of 9 times theta minus 8 pi over 18, and that goes to 2 pi. So now I have the guts of the problem, and now I can write my cosine function. Y equals 2 cosine of 9 theta minus 8 pi over 18 plus 1.5. Again, these are very similar, the sine and cosine curves. The only difference is the phase shift and where you're starting the graph. But the amplitude, the node, and the frequency should all be the same. So there we go. That's all you're doing. You're going backwards. The quiz is on this, drawing, tables, boxing out curves, and finding frequency, just like worksheet 1. So once you're done with this, you're ready to take the quiz on Tuesday. I will see you guys in class.